Okay, so in the last video we looked at what a tangent line is, and that might still be a little confusing to you, but hopefully as we go through these examples it'll kind of lock in. So, the first example, find the slope of the line tangent to f of x equals x squared plus 3x at x equals negative 2. We can normally, in the past, everything you've known so far, you need two coordinates to do the slope, all right? y2 minus y1 over x2 minus x1, but we don't need that now with pre-calculus, which is basically just calculus, and in calculus we can do the tangent line by doing what we learned yesterday. We can find the slope by using that formula. Okay, so I had a phone call and I got lost in my train of thought, but instead of starting the video over, we're just going to jump right to it. So I apologize if I was on a point, but I don't think I was. So we're going to find the slope of the line tangent at one single solitary point, not at 2 points. So what we learned yesterday, not yesterday, I keep calling yesterday as if each video was a day. Whenever you watched the last video, we had a slope formula. And that slope formula for a tangent line looked like this. M for slope equals the limit as h approaches 0 of f of x plus h minus f of x all over h. This is just slope. If you recall, go back and watch that video again. F of x plus h minus f of x, that's just y2 minus y1. The reason why there's an h in the denominator is because technically in the denominator we had x plus h minus x, the x values, and then the x's canceled and left us with just h. And so that's what this is. It's just slope. It is actually y2 minus y1 over x2 minus x1. The difference is we called the distance between the two coordinates we were looking at h, and our goal is to make that distance become 0. Now that distance can't be 0 for us to do slope because slope is reliant upon 2 points. But this whole idea of a limit allows us to look at what happens as we get closer and closer to that distance being 0. But if you recall, go back and watch some of those limit videos prior to this video. Limits don't care about what happens at the point, it's all about approaching it, right? That's why we made those tables. It was what's happening as we get closer to 0, not what happens when we actually reach 0. Because if we were to do the limit as we learned in the other videos, if we were to just take 0 and plug it in for these, for the h's, we would have f of x minus f of x in the numerator, which is 0, and then the denominator would be 0, and that's all kinds of bad. So we're going to utilize this formula to help us figure out the slope. Now we've got a variable that's going to change, the letter x. That letter x is going to change into the x that we're given in the problem. We have to be given it in our problem, and we are. It says that we have an x value of negative 2. So we're going to replace the x in this equation with negative 2, and so then our slope looks like this. And like magic, there we go. So replace the x, I misspoke, we replace the x's with negative 2 because that's what x, the x value that we're looking at. And so we have f of negative 2 plus h minus f of negative 2 all over h. We need to evaluate this limit, which means we have to figure out what is f of negative 2 plus h, what does that look like, and what is f of negative 2, what does that look like. So I'm going to start with the easy one. I'm going to start with f of negative 2. I'm going to do it over here off to the side, even though I don't really need to do it, but there's a point that I need to drive home for many of you. So if I want to do f of negative 2, no problem. I simply just replace each x with negative 2, right? We know this. This is not something that should be confusing for us. We learned this way back in integrated 1. So we get negative 2 squared plus 3 times negative 2. And that's easy to evaluate. Negative 2 squared becomes positive 4. 3 times negative 2 is negative 6. And 4 plus negative 6 is negative 2. It is coincidence that it ends up being the same value as the x value. Please don't assume this always happens. It is just mere coincidence with the numbers that I happen to pick. Now, that doesn't cause students any problems. What causes students problems is finding f of negative 2 plus h. And I don't understand why students have an issue with this. You had no issue with negative 2. What if I, instead of doing that, let me just throw some others at you. What if I asked you to find f of p? Well, that wouldn't be an issue. We would just replace all the x's with p, and we would get p squared plus 3p. Right? Now, it's not anything that we need, but we can easily do that. I like to extend it even further, and what if I asked you to do, say, f of, let's go triangle? No problem. I don't know what triangle is. I don't care what triangle is. That would just be triangle squared plus 3 triangle. I don't care what you put inside those parentheses. If I want to do f of smiley face, I can easily do f of smiley face. It's simply going to be smiley face squared plus 3 times smiley face. That's it. It doesn't have any meaning, no mathematical meaning, but we can still do this, right? So we're trying to figure out what is f of x plus, negative 2 plus h. Okay, well then replace all of those smiley faces or all of those triangles or the letter P or the letter X with negative 2 plus h. And so that's going to give us the quantity negative 2 plus h squared plus 3 times negative 2 plus h. Don't let the fact that it's not just a number or not just a variable cause you to suddenly think that math changes. Math does not change. It may seem like it, but it doesn't. Math has rules, and they are always followed. And so when we're going to do f of x, or f of p, or f of 2, or f of 7, or f of smiley face, or whatever, you just replace the x's with that. You just have to be very, very careful when you replace them. So that's going to allow us to come over here to our limit and replace all of that. So now I have that my slope is equal to the limit as h goes to 0. That didn't even look like a 0. That was just a dashed line. There we go. Limit as h approaches 0 of first f of negative 2 plus h, which we found over there. And so we're just going to put that here. That's going to be the quantity negative 2 plus h squared plus 3 times negative 2 plus h. Now, it can be very tempting to think you're done with the numerator because you have 2 terms, but you're not. All of that, I'll highlight it in blue, all of that is that and that alone. We then need to do minus f of negative 2, and we found that f of negative 2 from over on the other side of our board is negative 2 as well. That was just a coincidence, and so that portion needs to go there. It's important that we see that we have both pieces of information. I highlighted one in blue and one in red. It's really easy to forget some of that because we just move too fast, so slow down. All of this is going to be over h. And our job is to evaluate this limit just like we did in the last videos. If you were to evaluate this limit, the first thing you're going to want to do is plug in h. Trust me right now that every single time you do this, when you plug in h, you will get 0 divided by 0. If you don't, you're doing something wrong. You have to get 0 over 0 with this limit. There's no other way it could be. It can't be anything else. So I know I'm going to have to mess around with this. Thankfully, we did a whole bunch of limit stuff in the previous videos, so if you've practiced it, you should know some things to do to be able to handle this limit. What we're going to do here, and pretty much this is something you're always going to want to do when you have parentheses of things being multiplied or being, in this case, squared, you're going to have to multiply it all out. So there's a lot of algebra that's involved with this process. So we are going to multiply out negative 2 plus h squared. I'm going to do this quickly. I'm not going to go through this. This is integrated math 1 stuff, so this should not be something that causes you issues. If it does, just do a little practice. If you multiply out and go negative 2 plus h times negative 2 plus h and do all the distributing, you will get 4 minus 4h plus h squared. That is just the first parentheses. Make sure that you're not just squaring the negative 2 and just squaring the h. You have to write it out twice. Then I'm going to take that 3 and distribute the parentheses. And so 3 times negative 2 is negative 6, so I'll just write minus 6. And then 3 times h is 3h. Finally, in the end, I have minus a negative 2. Minus a negative 2 really just means plus, and so let's go ahead and go plus 2 all over h. At this point, I could plug in h. You are allowed to try and plug in that value anytime you want. If I tried to plug in h now, I guarantee you're still going to get 0 over 0. Until that h in the denominator goes away, there's no point in plugging in h because you're going to have a 0 in the denominator, which is bad news. And so we're going to keep going. Limit as h approaches 0. Notice I keep writing that because I haven't done the limit yet. Let's go ahead and combine our like terms up in the top. So first, that 4 and that negative 6 and that 2, if we add that all up, 4 minus 6 is negative 2 plus 2 is 0. Yay! And so that's going to be all gone. Our h's, negative 4h plus 3h, that's going to work out to simply just be negative h. And then we have plus h squared. And all of that is over h. No problem. If we try and plug in 0 now, clearly again, you're still going to see we get 0 divided by 0, so we got to keep going. In the numerator, we can factor out an h. And if we do that, we'll be left with -1 plus h in parentheses all over h. And here's where we find the success. Those h's will cross out, they'll reduce, and we're allowed to do that. We saw that in a video prior. And so that's going to leave me with the limit as h approaches 0 of simply -1 plus h. That's a limit that I can actually do. If we plug 0 in for h, we end up with -1. That is the slope of our tangent line. This is the work that I need to see you doing when you're asked to find slope like this. So make sure you're doing all of that work with the limit. I don't need to see the majority of the work over here on this side. Oops. I don't need to see the majority of the work over here, but the limit stuff we definitely need. So let's take a look at one more example to make sure that we've got this idea down. Okay, so for this next problem, find the equation of the tangent line. That is big. It's not just finding the slope now. We need the full-on equation of the tangent line. So we're looking for, in any form, y equals mx plus b, or other forms are totally fine, but we need the equation of the line. So if we want the equation of the line, you need two things. We need slope, and we need any random point. You don't have to have the y-intercept. Any random point will do. We'll see that in the end. We can find either one of these things that we want first or second. I'm just going to do them in the order that I've got them written there. So the slope. To find the slope, it's just like we saw in the last example. Our slope is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Now our x value is the x that they gave us, and our x is told that it is at 4. And so that's going to be the value for x when we plug into our formula. And so let me go ahead and plug that in. Okay, so by plugging that all in, we have f of x plus h, so x is 4, so 1 over 4 plus h, because f of x is 1 over x, minus 1 over 4, because x is 4, minus, all over h. That limit's going to be 0 if we plug it in. We have fractions here. We saw this in the previous video. The way that I'm going to deal with this is I'm going to multiply both the numerator and denominator by both denominators. So I'm going to multiply this by 4 times 4 plus h. And I'll multiply the denominator by 4 times 4 plus h. So let's see what happens when we do that. Alright, so when we multiply that out in the numerator, the 4 plus h and the 4 plus h will cancel, and that's why we just have a 4 left over with that first product, because this whole thing is technically in parentheses. And then the 1/4 when we multiply, we end up with minus the quantity of 4 plus h. You gotta make sure you put that in parentheses. And in the denominator, we don't multiply that out. We just do the 4 and the h together, and we get that. So now I'm going to keep on cleaning this, and we'll get the new slope. So our new slope, or our new equation anyway, if we clean this up, the limit as h approaches 0 in the numerator. 4 minus 4 is 0, but that negative sign's got to distribute, so we just get a negative h there. And the denominator we leave alone. Now in the denominator we have an h, and in the numerator we have an h, and that means that we can cross them out. Bye-bye. And so that's going to leave us with this limit. And poof, like magic, there's our limit. The h is canceled, and so we just have 1 over 4 times 4 plus h. I can do this limit. If I plug 0 in for h, I'm going to get 1 over 4 times 4. 4 times 4 is 16, and so we get 1/16. That's our slope. We got one of the two things that we need. The other thing that we need is the y value. Well, we already actually did this. To get the y value is just going to be f of 4, which means plug 4 into the equation, and we get 1/4. So now we have everything that we need. So, magically, we put this here. We got our slope is 1/16. We have our coordinate 4, 1/4. We can write the equation of this line. You can put it in any form you want. You can put it in standard form. You can put it in y equals mx plus b, slope-intercept form. I prefer this form. Y minus y1 equals m times x minus x1. It's called point slope form, and if you get to know this form, if you don't know it, it's going to be your friend next year for sure. Y and x without the subscripts stay y and x, so this is still a y. The y1 means the y value that you have, and we have a y value of 1/4. M stands for the slope. X without a subscript is going to stay x, and the other x is going to be the x value that we're given, 4, and you leave your answer just like that. See? Super duper easy. This is the work that I need to see for the problems that I'm going to assign to you. So poof, like magic, there it is. I will be adding to this assignment in the next video. This is just some quick problems that are going to ask you to just find the slope. You don't have to do this tangent line. So work on these and look for the next video for more problems.